Hello everyone and welcome back to Diksha Karnataka YouTube channel. Today we are bringing you the part 2 of the video Basic Mathematics for Physics. So if you have not seen our part 1 video, don't forget to click on the link below and check the part 1 video where we have discussed everything about you want to know about trigonometry in detail, in depth, whatever is required for physics, specifically for physics. We have not overloaded the part with all the trigonometry that you have studied in your past, only the part that you are needed to learn physics. That part is basically discussed in depth, okay, with all the concepts, some extra concepts that is not taught in your classes. That part is also discussed there. So don't forget to check on the comment below if you have not checked that. So let's start with the part 2. Another important video of this part is this series. Part 2 is calculus. Today we are going to discuss about calculus. Okay, what all you need to know about calculus to learn physics. We are not going to discuss about mathematical calculus, all the mathematics that is behind the calculus. But if you are in second PU and you are struggling with physics, then what all you should remember to understand physics better, that part we will discuss here. And if you are in first year, that is class 11th or in first PU, then also you should not miss it, because for you this part is completely new. You have not studied this so far in your board curriculum, neither in your board curriculum nor in your previous classes. So don't miss that. This is going to be very helpful in your future when you are trying to answer any competitive exam questions. Okay, so we will start with very basic thing called functions. Okay, what is a function? Function means anything, any expression, any equation where one quantity is represented with another quantity. Okay, for example, I have written here y is equal to fx. What is the meaning of that? Let me explain it to you. So suppose I have simple equation y plus 2x equals to 5. You have seen this kind of equations in the past, right? This is called an equation. Now if I write this as y is equal to 5 minus 2x, that is on my left hand side one variable, on my right hand side another variable, then this becomes a function. So we can write y as a function of x. We will say y is a function of x. Similarly, we can write x as a function of y, right? From this equation we can write x as half 5 minus y. So this is now x as a function of y. So if two variables are involved, we can easily interchange the variables and write one variable in terms of another. Now in case of functions, this is a basic representation without saying what exactly the values are, what exactly the equation looks like. In some cases you will see z is a function of x comma y. So basically there is an equation, hidden equation, that we are not showing it to you, because we can generalize many many calculations using just without involving any variables. Okay, there are some things that we need to remember, otherwise we can generalize this kind of equations. So in mathematics, especially in calculus, we represent all the unknown terms using this. So basically you should remember that functions is nothing but equation. Now in mathematics there are continuous function, discrete function, okay, with a singularity. There are different cases. Okay, we are not interested in that. You can learn that in function chapter in mathematics if you are interested. Otherwise, only thing that we want to tell you about function is when we are writing an equation. Function is nothing but an equation for physics. The equation will be given to you. Maybe they will say x as a displacement is a function of thing. Sometimes they will mention some like force is a function of displacement, some function of displacement. Now find this and that. So that can be done. So in that case you should know that this is basically an equation that we are not being exclusively told. So that is how it is it works. And in most cases in physics it will involve only two variables, in some cases three variables. That's it, not more than three variables. Now let's move on. Now we will do differentiation. So after function, next comes differentiation. Basically, when we differentiate a function, what happens? That is our objective. But before going into that, let's explain why we need to learn differentiation for physics. Okay, so why we need to learn differentiation for physics? Now I am giving you one simple example, that v versus t graph when an object is moving with a constant velocity, increasing simple velocity. Okay, so my mistake, this will be S. This will be displacement versus time graph, and it is moving with a constant velocity. It is moving with a constant velocity. Then how can you calculate the velocity of this object? How can you calculate the velocity of this object? You need to know, okay, how much displacement it has, what is the distance it traveled, what is the time it has gone by. S by t is our velocity, or it's our speed. Okay, fine. So you can calculate the speed easily, though even though I am saying speed, is basically it means velocity, because it's a vector quantity. So as long as we know displacement, as long as we know the time taken to cover that displacement, we can calculate the velocity. So basically, when this is happening in a constant velocity. Now if the velocity is not constant, then how can we calculate the velocity? So let us take another case. Let us take another case where it is like this. It is like this. So it is starting from origin, that is displacement was 0, and at the end it is reaching here. That means again at this point displacement is 0. At this point displacement is 0, right? Displacement is 0. Here also displacement is 0. So total net displacement is 0. Now how can we calculate velocity using this formula? So velocity is 0. That means object has not moved. So it is static at that position. Is it static? Is it static here? No, right? It has moved through the space and it reached a different position. For example, a train starting from station A and it is reaching station B. So both point its speed is 0. Now how can you say that it has not moved? Or for example, you starting from your home, you go to your college, then again you come back to your college, your net displacement is 0. But have you not moved from your house? No, not correct. You have moved through space and time and space, right? So at any point, at any instant, how rapidly its distance is changing with time, how rapidly its speed is changing, its displacement is changing with time, that is calculated using differentiation. So differentiation is very handy when we don't know, it is not uniform. When the values are not uniform, in that case we can calculate the velocity, or in some cases acceleration, other values as well. So this is very handy when we are not sure how it has exactly moved. In that case we can use differentiation. Now what is the differentiation? Differentiation is we take one quantity with a small. So for example, here we are taking t, because it is in down, okay, denominator. So we will take this small value of this, and in that time how its value has changed, we will take that. So basically we call this as dt and we call this as ds. So basically in that case we will say v is given by ds by dt. But this is not the complete velocity, this is the velocity at this instant, at some time, say this time is t1. So at time t1, at the instant time equals to t1, this will be the velocity. Okay. Now if you take this t1 to be here, you can take a different time dt and you can calculate the different ds, and this is true for any instant. You can take any instant of time, and you can just need to substitute the time value in the equation, and you can calculate the instantaneous velocity at each and every point. And what is the meaning of this? How rapidly this is changing with respect to this, how rapidly ds is changing. Maybe it is increasing, maybe it is decreasing. In suppose up to this point it it is increasing, from here it is decreasing. So, how rapidly a value is changing, that is called the differentiation. So, differentiation basically measures how rapidly one variable is changing with respect to another variable. Whatever is respect to, that goes in the denominator, and whatever variable is primary focus, that goes in the numerator. So, numerator is how rapidly this is changing with respect to this. Okay, clear? Any doubt? Don't forget to mention that in the comment. I will try to answer each and everything as crisply as possible, and if not, then I will definitely make a separate video to explain whatever doubts you have. There will be a doubt clearing session as well, so don't worry. If you have any doubts, mention in the comment. Now, there are few formulas. These formulas are handpicked only for physics. There are a lot of other formulas for mathematics, but I am only giving you the formulas that is required for physics. Other than that, I will use 2 more formulas. Okay, so that only be discussed in this lecture, nothing else. You don't need to remember difficult formulas. So, first of all, the differentiation is represented using this symbol ddx, okay, ddt, like this. So, this is the with respect to the term, with respect to what we are doing the differentiation, that is the denominator. And with respect to, suppose it can change from equation to equation. Obviously, if the equation is given in terms of t, then it will be a differentiation with respect to t. If it is given in terms of x, then it will be given differentiation in terms of x, like that. Depending upon the case to case, this will change. Now, remember that when we are differentiating a constant with respect to any variable, as long as we are differentiating a constant, its value will be 0, ddx of c. We say ddx of c. This is how we are we used to say these things. Okay, some say dc by dx. It is not accurate. Dc by dx, it is called ddx of c. You may say it is not accurate, but it is not incorrect. You can say whatever way you like, but it is said ddx of c. Okay. Now, when you differentiate, this is called differentiating. Now, remember that whatever this variable and this variable, whatever, this is your function basically. So, dx of some function we are doing. This is our process. Now, this function can change from depending upon problem to problem. Now, remember that this x and this x should be same. If there is, this is a function of, suppose this is a function of y, we cannot directly differentiate this. We cannot directly differentiate this. Okay, there is a different way of differentiating this kind of function that will be discussed in your mathematics class. Okay, provided y is a function of x, you can differentiate that as well, but that is not discussed here. That is will be part of your mathematics class whenever you are learning that. Okay, those who are in first year, they will learn in the second year. Okay, so don't worry about that. So, we are not interested in this kind of equation right now. What are we are interested in? Simple few differentiations. So, when you are differentiating any polynomial, this is called polynomial. Any polynomial, when you differentiate, it will be x to the power n. When we are differentiating x to the power n, after differentiating, what we will get, this n will come down. This n will come down. Okay, this n will come down. Okay, one n is reduced. So, what will happen? We will get one n reduced, right? So, one n came down. So, it will be reduced by 1. Simple. Any difficult? No rocket science, right? So, you have to remember this. In some cases it will not be. In some cases, it will not be. So, suppose ddt of 5t square, ddt of 5t square. Okay. Now, what will happen? How can we differentiate this? First of all, remember this. Usually, differentiation of a constant is 0, but when it is with a another variable, then we do not differentiate the constant, it comes out as it is. Okay, So when it is with a variable, it comes out as it is. Now what we have to do, we have to differentiate this t square term only. Okay, whatever constant is there. So if we are doing d dx of a x to the power n, then this a will come out as it is. We will only differentiate this based on the formula. So n x to the power n minus 1. Okay, any constant that does not affect our differentiation, it just comes out. So 5t square means 5 will be constant, it will come out as it is. Then t square ka differentiation, t square means x to the power 2. So first thing 2 will come out. Okay, 2 will come out, and then t to the power minus 1, 2 minus 1. So that means 10t. Understood how this is coming out in our real life? So this will be given to you, and you will be asked to find some values. Then you can do the simple mathematics. This is very simple. Those who are studying in second year, they are putting their head in the wall, saying that we have not understood that in our first year. Our entire first year is wasted, right? So those who are in first year, I request you, do not fall for the same trap that your seniors are already in. So focus here and learn these few simple equations, simple differentiations, so that you don't waste your time in first year, and learn everything in depth and use that in second year. And those who have lost their times in first year, just remember, you have had to remember this kind of simple things. And if you want more such videos, don't forget to click on the like button and write a comment, leave a comment below, and subscribe to our channel. Everything in this channel is free, everything. Okay, all the teaching videos are for free here. Now next is d dx of ln x. Ln, what is the meaning of ln? You will learn something in future. There is a term called log. Log means basically it's represented by a ratio. Okay, log is given by 10. I will explain that log part in our algebra part for a brief while. So log basically means log 10, and ln in physics it's very common. It is log base e. Okay, it is log base e. Log base e, it appears too much times in physics, so we generally represented that with ln or ln. Okay, you can write ln, you can say ln, whatever you are comfortable with. Okay, our teachers used to call ln when we used to say ln. Now I was confused, very confused. What is ln? Ln means ln. Ln and ln are same. Okay, don't get confused with this. Similarly, we have learned about ratio of angles in our previous video. So sin d dx of sin x is cos x, d dx of cos x is minus sin x. Cos is always angry, so basically cos transfers everything to negative. So cos d dx of cos x is sin x, d dx of tan x is sec square x. Okay, so everything, these are the basic formulas you need to remember, but most important is this formula. Most of the time where you will find this is the most used formula. Okay, this is the most used formula that you will find. Sometimes in some cases this is also important. For example, when you study SHM, these equations will come handy. Okay, so these are the very basic formulas that you have to remember. On this is an advanced level formula. If you are studying for JEE Advanced, this will come. Otherwise, sin, cos and this x to the power n, these three are the basic formulas that you need to remember, and not very difficult. It is not very difficult to remember. Only thing, you need to write it down in a notebook and study from them time to time. Now let's look into some application. So an object is moving with x equals to t square plus 2t plus 4. Okay, this equation is given. So basically what is given? X as a function of time, right? I already told you what is function. So basically it is given as a function of time. Now find the velocity of the object at t equals to 2 seconds. So what is the velocity? We know that velocity is given by dx by dt. Okay, if it is simple constant value, then it is only x by t, right? Velocity is x by t when it is constant. So if say it is given in 2 seconds is travelled 4 meter, then what is the velocity? Then we can calculate simply by x by t. But here it is given not a constant, it is a variable. So variable means we have to use differentiation. As soon as you see this is a variable, you have to use this equation. Now how can we do that? So first we have to write dx dt. What is dx dt? Tell me. So dx dt is basically when we are doing dx dt for addition, we can treat everything individually and apply the formula x to the power n individually. So first is this term. What is this differentiation of this? This x to the power n, instead of n it is 2. So it will come 2 and t square 2 minus 1, right? Now whatever sign is there except multiplication, all other signs are fine. Plus minus are fine. Multiplication and division are separate, that you are going to learn in your mathematics class. I am not going to discuss here. Okay. Now 2t, t to the power 1. So 2 into 1, t to the power 1 minus 1 plus 4. Differentiation of a constant is 0. So we can write 2t plus 2. Simple. Okay. So 2t plus 2. Now we are asked to find at t equals to 2 seconds. So what is the velocity at t equals to 2 seconds? This is the velocity in general. So v t equals to 2 seconds is 2 into 2 plus 2, that is 4 plus 2, that is 6 meter per second. Units will be given. Okay. So 6 meter per second is the velocity at t equals to 2 seconds. Now similar problem, let me make it little bit complicated. Similar problem, everything is same. Okay, everything is same. Let me make this problem a little bit complicated. Now let's make this problem a little bit complicated. Okay, how can we make this complicated? We have just converted t equals to x. Let's take this 2 as 3. Let's take this 2 as 3. Now similar problem, everything is same about this problem. Only thing is now t is given as function of x. T is given as function of x. Now how can we solve this? So what we have to find? We have to find velocity. Velocity is given by what? We know that this is given by dx by dt. So there are two ways to solve this. You can take and solve everything and you can simplify this and then find everything, convert that back to in t form and do the mathematics. That will be very, very complicated and long problem, but there is a trick and it will be very simple. So what is the trick? We know t is given like this, right? So what we can write? We can write dt by dx. I am not saying ddx of t. Okay, remember that we are not saying ddx of t. I am just simply saying dt by dx. There is a reason behind that, you will understand soon. So dt by dx, what will be the value? It will be 2x plus 3a, right? Constant will be 0 and this will be simple like this. Now what we have to do? We have to t is 2 seconds is given. T equals to 2 seconds is given. So basically we are trying to find this, right? So this is, if you take the inverse of that or you reverse this, simple like division, dx by dt, then this will be 1 by 2x plus 3, right? It will be 1 by 2x plus 3. Now what we have to do? We have to put we have to find the value for x when t equals to 2 seconds, right? We have to find the value of t x for t equals to 2 seconds. Now what we will do? We will put t equals to 2 in the equation, x square plus 3x plus 4. Okay. Now take this to another side. What we will get? X square plus 3x plus 2 equals to 0, right? Now we just need to do the midterm. So x plus 2x minus plus x plus 2 equals to 0. And then take x common, x plus 2 plus x plus 2, right, equals to 0, or x plus 2 into x minus plus 1 equals to 0, right. So basically value of x is either minus 2 or x equals to minus 1. Okay, both values we have to put and find the value velocity for that point. So there will be two answers. There will be two answers for this problem. First velocity will be 1 by minus 2 means minus 4 plus 3, that is minus 1. Velocity can be minus, right? It is going in the opposite direction. Now let's put x equals to minus 1. So v equals to minus 2 plus 3, that is 1. So in one case it is minus 1, in another case it will be plus 1. Now if the option is given, if velocity is positive only, then positive means plus 1, negative means minus 1. Okay, simple problem, but the problem is not very difficult. Problem is not very difficult. Only thing you need to know that you can just do this as well. So you can simply do the mathematical, simple mathematical. So if it is a by b, okay, is equal to say c, you can write b by a equals to 1 by c, right? The same thing is applicable for differentiation as well. Okay, in trickier cases, because there is some mathematical properties using that, you can do that. In mathematics, teacher will say they are not same except some cases, but in physics they are same. Okay, because those that some cases are actually applied to physics. Okay, now we have already solved this. Next, we'll look into the integration part. What is integration? What is integration? So let's take the similar example where we were discussing about ST graph. Now we are discussing about VT graph. In the VT graph, suppose the velocity is constant. Velocity is constant, it is moving in a straight line, that means this is the constant velocity, right? This is the constant velocity, and it is you are asked to find the displacement. Displacement is basically S equals to Vt, right? So you can take this V, this V and this T, you can say okay, this is the area, that is the displacement, right? Area under the Vt graph represent displacement. So this is the simple way to calculate the displacement. Now what will happen, instead of this the graph is like this. The object moves with a variable velocity. Now how can you calculate the displacement? The formula for displacement is same, but you cannot simply apply this formula. What you have to do, you have to take a small piece, okay, in that piece whatever the velocity is, okay, and then you have to apply, suppose this velocity is v1 and this time is dt. Okay, so what is the area of this region? It will be v1 dt. Similarly, you take another region with another velocity, say v2, okay, and the same displacement, then it will be v2 dt. So if you take all such small portions and add them together for corresponding velocities, if you add them together, then whatever you will get, that is represented using another mathematical process called integration. Okay, integration, okay, function dx. This is how it is written, and basically in physics most of the cases it represents this only. There are some other cases as well, but basically integration means area under the graph. Integration means area under the graph, and it is starting from somewhere, ending somewhere. So we are this is called definite integration. We will discuss about that in a little while. So this definite integration is only what is required in physics. Indefinite integration are mostly not required in physics. Okay, so we are starting from somewhere, say v equals to 0 t equals to 0 and say t is equal to 5. So we are doing, this is called limit, and we will put that here in depending upon the problem. Okay, so this is the integration process. Now let's move on. So basically integration means area under the graph. Now integration formulas, similar to differentiation, there are few formulas for integration as well. So what are the formulas? A dx, a is a constant. If we are in case of differentiation, when we differentiate a constant, we got 0. For integration it is not 0. For integration it is ax plus c. Whenever we are doing an integration, there comes a constant. there comes a constant. In general, it is coming in mathematics. In physics, we generally do not use plus c because 99% cases we are using definite integration. I will explain why there is no c for definite integration, but for mathematical purposes, to be accurate, so that someone can come and comment in the comments, sir, you have written a wrong formula, there will be plus c. So I have given the mathematical formula here. Okay. Now, similar to differentiation, when we are differentiating x to the power n, we got n into x to the power n minus 1. So there it was reduced and the value multiplied. Here what will happen in case of integration, this value will be added with the plus 1 and that plus 1 value will be divided. Okay, remember this. So if we say integrate t square with respect to dt, what you will get? You will get t square means 2 plus 1, that is 3 by 2 plus 1, that is 3, that is t cube by 3. Okay. So, unlike in differentiation, integration is increasing. In differentiation it is decreasing, in integration it is increasing. Basically they are opposite to each other. So integration is basically opposite of differentiation. So in case of differentiating ln x, we got 1 by x. So when we integrate 1 by x, we get ln x. Okay. Similarly, when we differentiated cos x, we got minus sin x. So when we integrate sin x, we will get minus cos x. Cos x, for cos x it will be sin x. So whatever differentiation we get, while doing integration we get the reverse. Okay, that is also simplify thing that you should remember. So basically, what is the meaning of this? I just wondering this. This is basically means x to the power minus 1 dx. So this formula is valid for all n except n equals to minus 1. This formula is valid for all n except n equals to minus 1. Even minus 2, minus 3, minus 5, that also you can apply the same formula except minus 1. When n equals to minus 1, you have to use this ln x. Okay. Other than that, this is valid for all the other integration calculations. In differentiation, there is no such thing. You can apply it for everything, all the n's. Definite integration, that is the main purpose of this part of the lecture. What is definite integration? Suppose we are doing integration of a function fx with respect to dx, and we are getting a result gx. For example, I gave the example t square differentiation with respect to integration with respect to dt, we got t cube by 3. So basically this is the t cube by 3 part. Okay, a new function is coming and with a constant. Now definite integration means when we starting at a point and we are ending at a fixed point. So we are starting at a fixed point and we are ending at a fixed point. So basically when this value, a variable x, starting at a and ending at b, starting at a, ending at b. Okay, so this is our final value, this is our starting value. So a to b. So it is written as integral a to b fx dx. Okay, so a to b means starting point is a, ending point is b. So basically when we saw that graph, okay, so we are starting here t equals to 0, this is our a point, and we are ending at t equals to 5, so this is our b point. So basically when we do the integration, say this variable is fx. Okay, so when we do integration, we will say a to b, not a to b, it will be 0 to 5, 0 to 5. Okay, this fx is say t square, it will be t square dt. Okay, this is how we write. So function is given dt, and lower limit, upper limit. This is called lower limit, starting point lower limit, upper limit is the final position. Okay. Now if you do the integration of this normally, you will get a constant, right? While doing the definite integration, what we have to do, we have to put the value for b at this instead of x. For example, what is the integration in this case? Integration in this case is t cube by 3, right? Normal integration with a constant. Okay. While doing the definite integration, what we will do, what we will do, we will write this as like this 0 to 5, and we will put this 5 value instead of t. So 5 cube divided by 3. Okay, this is called upper limit. First we will put upper limit value. Instead of t we have put 5. So instead of x we have put this value b, upper limit, minus lower limit was 0. So 0 divided by 3. Understood? So 125 divided by 3. This is the answer. Okay. So similarly here also we will put the value for b and we will put the value for a. Okay. Now this constant was here also, same constant over here also, but there is a negative sign. So these two constants cancels each other. So that's why while we are doing physics, while we are doing definite integration, there is no constant. Okay, we do not need to worry too much about this constant. Otherwise you have to do boundary value problem. When you do the mathematical part, there will be boundary value problems where you have to use this and find a value of c. That is not required in physics. Okay. Now let's solve one problem. Force acting on an object as a function of distance travelled is given by F equals to 3x square plus 2. Calculate the work done to bring the object from x equals to 2 meter to x equals to 3 meter. A simple problem. Those who are in first year, they may not be familiar with this concept exactly, but I am just giving you the formula that the work done is basically given by F into x. Force into displacement, that is the work done. Now in this case, when the force is constant, say 5 Newton, 4 Newton, 3 Newton, in this case force is not a constant, force is varying with x. So how can we do the work done? To do this in this kind of cases, what we have to do? We have to do F dx, okay, from starting point is 2, ending point is 3. So 2 to 3. So basically this is the way of calculating the work done for variable forces. So 2 to 3, we will just write this value 3x square. These things will come, these formulas, these equations you will come with time, but I am just giving you an example how to do the integration, okay, in our case. So this is the dx. Now what you have to do, you have to do the integration first. So how to do the integration? 3x square. 3x square means what I said, 3x square 2 plus 1 divided by 2 plus 1, right? So whatever is on the top, that should be in the divided, plus there was x to the power 0 here, x to the power 0 here. So we can write 2x to the power 0 plus 1 divided by x to the divided by 0 plus 1, right? So and outside we will write, now since the integration is completed, we will write from 2 to 3. This is how we write. This is how we write the integration. Now what will be the value here? The value will be 3x cube by 3 plus 2x. This will come with time. Once you are practicing this kind of problems, this kind of things regularly, you can directly write this. You don't need to do these steps. Okay, I am just doing it for explanation. Once you are doing it, you can directly write these things. Now put the value, first will be upper limit. So we will write 3 cube plus 2 into 3, right? Every x will be replaced by this value, minus lower limit, minus lower limit. What is the lower limit? Lower limit is 2. Okay, so lower limit is 2. So it will be 2 cube plus 2 into 2. Okay, so what is the value? 3 3 is 9, 3 9 is 27, plus 6 minus 2 cube means 8, this means 4, 12. So 33 minus 12, that is 21. Okay, and this unit will be joules. Okay, so I hope you have liked this video. So if you have not yet subscribed to our channel, don't forget to click on the subscribe button, click on the like button. If you like this video, leave some comments below if you have any doubt, any question, and we will come back with part 3 of this lecture, where we will discuss about graphs, and part 4 where we will discuss about algebra. Thank you.